Hi, welcome back, guys. So, today's topic is bias and variance in machine learning. So, we will talk about bias or underfitting, variance and overfitting, and bias and variance trade off. So, what is bias? Bias is basically the inability of machine learning algorithm to understand the underlying information in the data, which is also called underfitting. Underfitting is the result of excessively simple model and it has high training error, while variance is an error in the small fluctuation in the training set, which is also called overfitting. So when the model fits the training data too well, but it fails on the generalizing the new examples, so it has high testing error. Bias refers to the training error and variance refers to the testing error. So let's take an example to explain underfitting and overfitting. So let's take an example for linear regression. In linear regression, we have like first degree polynomial, second degree, and fourth order polynomial. So in the first order polynomial, the line does not fit the data well. So this model is too simple. So it has high training error. So it is called underfit. So high bias and underfit condition. But in case of fourth order polynomial, the data, the line or model is fitting the training data too well, but once you show the machine a new example or when you change a little bit in the training data, it, it it will fail on the new examples, so it will have high testing error but low training error or zero training error, which is a condition of overfitting. And in the just right condition, you have second degree polynomial which has small training error and small testing error. So introducing a little bias in overfitting condition will give you best results. So it will reduce your training error and testing error. So we want in between underfitting and overfitting condition, which is a just right condition. So let's take an example of classification. In classification, you have three decision boundaries. So first decision boundary is not classifying the two examples well. So this is a condition of poor or underfitting condition. So which has high bias and high training error. While in case of overfitting, the boundary is decision boundary is little complicated and it is basically classifying the two points well, but it will fail on the new examples. So this is a condition of overfitting. We don't want this condition too. We want a model which is basically generalize the new examples too. So we will want a appropriate fitting or appropriate boundary which has small training error and small testing error. So what we need to trade off between bias and variance. So if you want to classify like cat or dog, so what you need to do, you need to understand the difference between training error and testing error. So you need to have comparison. So for example, if you have like 1% training error, suppose, and 15% testing error, so it is a condition of high variance, overfitting, because you the dat the model is machine learning model is fitting the training data too well, but failed on testing data. And if your training error is too high, and you will have high bias or underfitting condition. And then if your both training and testing error is high, you have high bias, high variance. And in the fourth condition we want, where your training error and testing error both are reduced. So total error in machine learning algorithm is, or machine learning is bias and variance. So what you want to reduce bias and variance. In order to reduce high variance or overfitting, you need basically more data, and data can be achieved through augmentation, but it's always expensive to get the more data. So we usually use regularization or dropout method, which we will discuss in the next lecture, and more in logistic regression and linear regression. And in order to reduce underfitting, you need bigger network or you need to train longer. Why? Because underfitting is a condition or basically the problem of our model, not the data. If you have more data, it will not work out. So you need a good machine learning algorithm in order to reduce underfitting or high bias. So getting more data and using a good network or bigger network will reduce both bias and variance. So one technique to get good data, cheap way of getting data is data augmentation. Data augmentation is basically showing this, basically changing the poses of image. For example, if you have a cat image, you can basically get the different poses of image, sideways, or you can flip the image sideways, side, and then you basically in a different orientation using crop method or flipping method. So you can get basically more data and you can show the machine more features. So this basically will reduce the overfitting condition. So this was today's lecture. I hope you have now clear understanding what is the difference between bias and variance, and how you can get the, how you can do the trade off, and how you can reduce the overfitting and underfitting, and how you will reach a trade off between bias and variance in order to reduce both variance and bias. So please subscribe and like my channel so for more upcoming videos, and we will talk about in the next video a very good technique of regularization. So stay tuned and like my channel and subscribe it. Thank you so much, guys.